use cases in the, so we have use cases in this examples document that demonstrate how to use different concepts, the different component types, dependency types, and an example basically based on, I would say, on a network scanning view, what you would see, what crypto assets you would see in a network scanning view. And right, so I think, yeah, what you said, right? I mean, what would be useful is to compile a document with, yeah, use cases, right? So try to get a good list of use cases and then see, and then just to check, right, that this can be addressed with the CBOM as we have it right now.
Yeah, exactly. No, I think that's fair, and that was completely my bad that I did not get that document created. Right now, I'm just trying to reboot my machine, just one step at a time, I guess. Let me switch over to my other one here, and
maybe just that time a general question. So from the use case perspective, do we go over there from the more high level use case, or do we start from like a deep technical and then going upwards? So I'm just thinking if we.
Yeah, I think if we start at the high level, in my opinion. Okay. I mean, the technical stuff can kind of work itself out as we go into the weeds on some of the stuff, and you guys have already figured a lot of this out. So okay. It's the high level use case that really introduced design decisions that I'm really curious about, because once you get a design and then you put it into a specification, if that design is incompatible with some high level use case, then that certainly is an issue. The yep. Technical stuff is easier. It takes a lot of conversations, obviously, to work it out, but at least you don't have to affect the design in most cases.
Okay. Just because from the example page we have, this is more like from the technical side, the use cases. So like how to express certificates, how to express algorithms, but not like from a high level use case perspective. So.
Right, exactly. Yeah. So I think we're going to be looking at the use cases from the opposite perspective, which I think will be a valuable exercise anyway.
Yep. Okay.
I think it would be a good exercise, right? If we can collect those and then we can extend our document as well to cover some of those use yep. cases, right? I mean, what I can see, for example, is, I mean, the use case that we have in the examples page is, let's say, what you see from a networking scanning perspective, right? Where you have, so maybe I can quickly share my screen with that page. So you should see my screen right now.
Yes.
So this is something, right? So we would basically here you would scan the network, right? And you will see a service, right? Or you would see an application like Nginx, which in this case uses library libSSL from OpenSSL, which in turn implements TLS, this case, TLS 1.2 network protocol, and which in turn uses a couple of algorithms here, ECDH, RSA, AES, SHA-1, and there's also a certificate involved in it, which in turn also uses a signature algorithm and a subject public key, which is for certain type and might be secured as well, right? So, I mean, securing a public key might not be the best use case, but if you have a use case with private key involved, I mean, that's something where this could then be extended to. Usually a private key is secured in a hardware security module, for example. And in this situation, and we have these two CBOMs here. The first one only uses classical algorithms. So you will see here all the algorithms here involved as the type algorithm have NIST quantum security level 0, which means that they are not quantum safe. So if you do kind of vulnerability analysis on that, let's say it's possible to infer that it's not quantum safe. While the second example that we have here, it's basically the same thing, but instead of using RSA and ECDH, we use Kyber and dilithium, which are the quantum safe standards that are now, I think just today, NIST published FIPS drafts for these algorithms. Right, and what we see here, okay, that's actually a typo. So that's it. NIST quantum security level should here be 5, not 0, right? But you basically will see it. It's a typo here. But here you see Kyber 1024 is quantum security level 5. So I think, I mean, that's more, you know, what you said, like Nicholas, it's more on the technical side, right? How we express the different properties here, but I think that's one example. And yeah, if we can collect different use cases, then we can do similar examples like that and try to have examples for them as well, right? I mean, what I can see, for example, I mean, last time I think Steve, you mentioned or you brought up the services, right? Have you, yeah, if you just know your endpoint is a service, right? How can you, how can we connect that with crypto assets or crypto asset components, which I think is possible, right? I mean, we can also use dependencies and dependency types there as well. And other things I can see is more, let's say, on the design side, right? If you design a software, right, you can already build a CBOM. There we have an example that we can use, for example, from Open Quantum Safe has a CBOM built from its documentation, algorithm documentation. I think some other use cases could be for, let's say, if you have a source code scanner that identifies crypto assets in a software, including its dependencies. Right, others like during the CI/CD process, right, where you build software, what could be, yeah, what could be built there. Or if you use, if you look at a deployed system and the configuration files that actually determine what crypto is in use, right? That I think would be another interesting use case to build a CBOM from that, because yeah, it's yeah. If things are not hard coded, right? It's a good design pattern not to hard code, then it's in a configuration.
Yep.
And then I think one use case that occurs often is that you need to show that something is FIPS in FIPS mode, right?
Yep.
There we have properties as well. So just a couple of use cases on top of my mind that might be useful too.
All right, let me start capturing those. I created a CBOM high-level use case document. Welcome, Matt, and shared the link to that in the cryptography Slack channel. But I can probably paste it in the Zoom chat as well. Let's see, where's my Zoom chat? Where's my Zoom chat? So I think the first two use cases that I think you have technical examples for are really about deprecated and obsolete algorithms, right?
Right. Yeah. Yeah. It's mainly in connection with their security level, right? So that's the use case that we have. So yeah, weak cryptography.
But is that the level we want to defend the use case? I was more thinking about something like supply chain security from a crypto perspective, like a little bit higher, or crypto inventory. If this is like use cases, or I mean, these others a little bit more specific and target to something what you want to do or like actionable. But
Yeah, so you're right. We talked a little bit about PKI and just having a list of well, just kind of like SBOM, right? Just a list of ingredients.
Hmm.
So what should we call that use case? It's not really PKI. It's
So just a list of ingredients in terms of an inventory, or I can't get the relation to the PKI currently.
yeah, it's really about asset management, right? It's really about capturing what it is that you have.
Hmm.
And then once you actually have that list of things, then you can actually start doing stuff with it, like
Hmm.
finding weak ciphers, weak algorithms.
Exactly.
So
And forcing policies.
it's just a variant of inventory. The question is, are we going do we want to create variants, cryptographic, go through the list of all the use cases in the CycloneDX use case page and see if there's a, apply a crypto variant to see if what the delta is, because most cases are going to be similar. The inventory for crypto is going to be specific to different media types, or different ciphers, algorithms, and things like the inventory might different granular assets types. But I mean, if that's what we want to do, then we can be, that's exhaustive. That's an exhaustive approach, right?
Yeah, I'm not really interested in that, but things like this, right? First of all, I think the asset stuff is simple. We're not going to go through that. Discovering weak algorithms, quantum unsafe algorithms, these are things that the CBOM spec in its current form already do. We can do FIPS 140-2, for example. Which I think
Profiles. You're looking at profiles?
Yeah, just different types of high-level use cases, right? Like if I wanted to discover, like if I'm using any algorithms that are not FIPS certified, right? I can do that.
And I still, I thought you were going to, like I said, it may be good, and a good exercise to go through the list of use cases on the CycloneDX. I still think it's valid because we need just affirming where those use cases are applicable to crypto, just having like a checklist saying applicable or not applicable, and tease out if if we have the right data to account for the new types of assets.
You talking about the use cases and examples page?
Yeah, I mean, I think as a positive affirmation that all the normal things you have for a normal piece of software apply, plus these extra ingredients here and there for crypto, like each one has a special consideration potentially, or a special, paragraph or something informative thing that you would have, or examples that are specific. If we assume that, and I assume what I've seen in the CBOM schema, it's all these, it's complete, but I just think it's a great exercise anyway, because you'll hit upon pedigree, provenance, signing, completeness. Anyway, but I understand where you're going. So what what you're saying is, let's take it through some different profiles. So I think the profiles fall in two categories: is accounting for existing ciphers. Well, that's all it is. It's accounting for existing ciphers, and yeah, and then making sure that I think from the enumerations that we saw in the various fields that it covers a lot of things.
Yeah.
So in terms of what you're trying to do is if you're trying to say, let's have a controls-based framework against some security certification with a set of controls and audit. You're auditing something from an auditor's, so the persona would be an auditor against some known framework. Those are in like a higher order use cases, of course. But yeah.
So let me Let's see, let me share. Okay, can you see my screen?
Yes.
Yep. All right. So over on the right, we have the high level use cases of what, CycloneDX actually does. Inventory, I think, is this is going to be obviously supported. You had, I think, in the CBOM spec, you had a node component type cryptographic asset or something like that, right? Did you have one or two new fields types?
We had one new field, cryptographic asset,
Mhm.
crypto asset, and then and this one then is subdivided in a couple of different things like algorithms, protocols, certificates, keys,
Right.
related
Okay.
material.
Yep.
Right.
Okay. Yeah, because you had underneath that, then you had the crypto properties, right? And then all that stuff kind of was under there.
Yeah.
Yep.
Yeah. Okay. So known vulnerabilities, this is really only going to apply to implementations. I guess it could apply to the actual algorithm itself.
Yep.
Exactly.
Yeah.
We
Right.
we have currently a POC implementation for something like that. So we thought of using the CBOM as an input and something like a REGO rule, and applying it through OPA to validate if an algorithm is weak or not. Like this is how we currently detect vulnerabilities based on a CBOM thing, which is not implementation specific. It's more like CBOM specific.
Yeah.
And did you find that the existing vulnerabilities support was adequate to represent a weakness or vulnerability in an algorithm itself?
I mean, I mean, it could be, but I don't. It's not that dynamic, I guess. If you have like a specific implementation weakness for an algorithm in a specific application, in comparison to just analyzing the generated CBOM compared to a rule that says if it's a weak algorithm or not. So, yeah, that's why we choose a little bit the dynamic to be able also for unknown software to say if the crypto is weak or not. The CBOM is there.
Yeah.
There are
I
two,
assume that. Go ahead.
yeah, there are two aspects, right? I mean, this dynamic part, and the other thing is more like the using the existing vulnerabilities and weaknesses. Let's say if there is if we have a version of a software that has a vulnerability, basically an implementation error of a certain crypto algorithm, right? Then there will be a CVE, right? So this is I think the normal approach, right? And then the approach we are using is then more analyzing the whole CBOM properties, right? And then you can create your own policy, kind of, right? That says we allow triple deaths or we do not allow triple deaths, right? It's not such a, I mean, there are situations where it's still allowed, right, in some policies, and then so that's a dynamic thing, right? So, and then depending on the policy or the rules, we can then define a vulnerability or a weakness.
Well, I guess in my mind, and like I was trying to figure out what what makes the cryptographic assets. How does that change how you approach vulnerabilities? And I see two cases. One is I think you both were describing, which is we'll have the traditional vulnerabilities that appear in implementations and software stacks, and even in base languages and things. We'll have vulnerabilities, CVEs, and the whole cert process come in. But the second part, what you were describing, Basil, begs the question of if how do we, do we have a report like a vulnerability? We have a vulnerability report of VDR. Is there a safety report, if you will, a quantum safety report. So that goes, I think that's my question in my mind. Yeah. Or is it because the government likes their reports and loves now we have this open VEX thing for vulnerability. So, what would the government want us to produce, in terms of information that a customer would want to know once you create an evaluation of safety, and how do you track that? Or, what are the remediation steps, or what things like that?
I mean, the vision currently is to take those policy implementation POC to build up like regulation frameworks to translate, for example, I don't know, CISA requirements into policies to be able to state if those apply or not based on CBOM input and those policies we define, and then you can generate a report from that or something. Yeah, but it's more on the regulation side.
Yeah, the thing is, we've actually crossed the line where we're producing such reports, or the majority of the data for the reports within the BOM itself in terms of VEX data. So do we use VEX data is VEX data sufficient, or is there a different set of remediation steps or states that something would go through if basically what information you need to produce to evaluate the policy and actually perhaps even track software that needs to change, that fails a policy, and track it through the states of remediation and fix.
Yeah, I think VEX is geared toward vulnerabilities, and in some cases, what we're going to find is that we're not talking about vulnerabilities at all. We might be talking about weaknesses in an algorithm, whether it's safe or whatnot. And we're also going to be talking about configurations, which neither one of those have anything to do with vulnerabilities. Vulnerability is a technical defect that leads to a security issue. In a lot of cases, these algorithms, that they're weaknesses, right? If you look at something like ancient, like MD5, is MD5 vulnerable? No, it does exactly what it was designed to do. There's no defect. It's just not a strong cryptographic.
Yeah, exactly. This is a new concept, I'm saying. Exactly.
Right, exactly. Okay, so we're saying the same thing. So my question to the group is, I'm actually kind of leaning toward, so we've got this concept of vulnerability, and I'm almost wondering, now that we have SaaS bombs and you can actually do automated threat modeling in some cases, so being able to produce threats, those threats comprise of weaknesses, and we have kind of a need to express weaknesses here, I think, as well, right? What is a weak cipher? If you were to communicate out, hey, I'm using these particular algorithms in my application, we're also expecting that consumer of that CBOM to actually know anything about these algorithms, right? I think it would be really beneficial if we could also express not only what the algorithms are and maybe their NIST quantum, security levels and stuff, but also the fact that it's just a generally weak or strong cipher.
Yeah, I mean, we try to capture that, let's say, in the security level. I mean, if it's weak, it generally means that the security level is below a certain threshold, right? If it's below 128 bits or 64 bits or so, it's something that can be derived from that information as well. And then for that's also the case for MD5 or so, right? And yeah, probably have to think if that's sufficient, right? Or if there is something more needed to capture that. And otherwise, I mean, one example that we have in this POC with weaknesses is, for example, you might be interested if your CBOM is compliant to I mean, there's the CNSA 2.0 document that says that from 2025 you need to support a certain set of algorithms, right? And then you would have your CBOM run a rule check against this, and then if it detects there are these quantum safe algorithms available and no algorithm otherwise is not on the list of approved algorithms, this will be a weakness in that case, right? So we have if you're not compliant with this, then we have a weakness, right? So, and that's depends on that policy. If you have a different policy that applies to now, right? It's not 2025 yet. The same CBOM would not raise this weakness, right?
Right.
So that's
So again, it takes me back to what I said earlier. Is that we assume the entire thing about bombs, whatever, regardless of what type they are, is we assume that somebody has a policy that we're trying to make better in terms of software component verification standard SCVS things to say is, do we have the mature data that we need to evaluate the policy, basically, and potentially, and that, but that the back end, like I said, we've hit the gray area of, or actually support formal within the bomb itself or separate in a separate file, structured weakness data or vulnerability data in the case, right? So it's a matter of not just acknowledging the typical policy, gather data, evaluate, enforce, but it's the reporting aspect that's already in the bomb that I'm asking if we need that concept for this, or can we augment, because it clearly is different from VEX. It's clearly different from that type of data.
I mean, we can't really reflect it in the WAX context, but I agree with you that this is not like appropriate for this use case.
Yeah,
So
we might want to let's chat a little bit next time. We'll table the weakness thing for the time being. We'll definitely come back to that.
And as you say, Steve, we don't have to solve it all in 1.6.
No, we don't.
But just acknowledging the use cases, acknowledging that these things should be worked on or discussed further beyond 1.6 is valuable.
Yes, absolutely. Absolutely. Okay, let's move on. Integrity verification. Is this even applicable? I mean, I guess for implementations it would be, but for algorithms, I don't think so. I can't think of a use case for this, but
I have a lot of use cases for AI that come to mind. Anyway,
okay. What, for using hashes on a
like for large language, am I using this model? Or, how do I verify behind the scenes that I'm really using this model?
Oh, yeah, of course. Yeah. Yeah. But in terms of actually using a particular algorithm, yeah, I can't. Implementations, yes, but yeah. Authenticity, so signing that block, yes, I think that's applicable. This is really about package URL. Yeah, I can't see that as being applicable. Licensing.
Just one point, because you mentioned package URL. We still we decided in the first place to define identifiers for algorithm based on package URLs, but then the second thought, it doesn't make really sense to have package URLs for algorithms that are not like packaged. So there's still this question about how we choose a good, meaningful identifier for algorithms that are, so they can be, identified again.
Yes.
Some form of an IRI.
You guys are using enums right now, right?
Not for identifiers.
Not for identifiers?
No. The best component we can use here are OIDs, but they are not always there. So yeah. Otherwise, we use just a like a specific format to describe algorithms, like with key size and the name. So like a variant string to identify, but it's not very, very good, I guess.
This sounds like a thing for the taxonomy, Matt.
Yeah.
Okay.
I mean, I know that when I first encountered or after I encountered your work in CBOM, I came across at least 2, if not perhaps 3 registries. So there is an analog, right? So there are groups trying to create registries. Am I misremembering?
Registries for algorithms?
Yeah.
I know like the Java, how they name things is almost similar, but not the same, not identical to the way OpenSSL like uses the names its algorithms. Because they're not the same. They're close. I'm not aware of any other formal things though. Maybe somebody else is.
Yeah, by the names themselves, I think there isn't really a standard for that. I mean, within OpenSSL, yeah, within Java, yeah, but it might be different. Also, for example, elliptic curves, right? I mean, there are standards, how they are called, right? Different standardization bodies. So it's sometimes it's even the same elliptic curve, but they have different names, right? So it's
Right. Okay, so that's something we're gonna have to flesh out. Now, you guys, are you just using right now? It's just a string field, and you just have a convention that you're using. Is that what you guys are doing?
Yep. So in the 1.4 1.5 version, we put a part in the README for describing or explaining those package rails and how they are created, or how you should create those. They are basically in the form of you have the first field, I think, name space is crypto. Then you have the asset type, so if it is a certificate or an algorithm, and then basically what follows afterwards is for algorithms like the variant, and then the version would be the OID, or for certificates, it's more like having a domain name and then the hash of the certificate file as a version attended. So yeah, but just we just give it some source and then wrote something down, but it's not, best,
Okay.
I guess.
Okay. We should
Yeah,
probably
right,
take
we
a deep.
capture in the algorithms that I mean, there are always variants, right? There is RSA, but there is RSA used in different with different paddings or with different or AES, right, used in with GCM mode or with ECB mode with different paddings, and then the convention how to express that in that string, like AES.
That's why the configuration, I think, is going to be really important.
Well,
Right.
that's the problem. I guess my problem is my background is the black book. So every implementation seems to have a black book of initializers, initialization vectors, seeds, and different, like Basil, they're totally different padding mechanisms depending on implementation. So yeah. And also, like, if you're doing streaming, you've got to worry about, packet sizes, for example. So if you're encrypting packets, I don't know if there's applicability to quantum safe, but if we're doing streaming stuff, particularly streaming stuff, then you have to have specific packet sizes where the quantum where the cryptographic algorithm has meaningful encryption. Otherwise, it's unsafe. Basically, if there's got to be parallels, right? So So I know that we were streaming videos. We had to have a minimum packet size. We had to make sure we had to actually obfuscate the last packet so people could work backwards and decrypt the last packet because it was sparse. It would only have like 2 meaningful characters, and if you zero padded it, it would give people an easy attack vector to decrypt. And once they figured they could work backwards, decrypt the entire packet stream. So, anyways.
Yeah. Yeah, this, I mean, there's algorithm variants, right? And if you choose a wrong padding, then it can be insecure, right?
Yeah.
And whatever, I think this is like streaming protocols, right? I mean, that's something I think that fits into the protocols asset type that we have. And right, I mean, the most common thing is TLS or IPsec, but there are much more there, right? But they, I think that would fit there.
I mean, maybe one other comment to the identifiers, since we maybe would not use those identifiers to find vulnerabilities in some database, like we did for packages. Maybe we don't need like an identifier that is globally like usable. Maybe you just need in a CBOM an identifier to separate different crypto assets, because we then parse it by something and some other tool, and then we have just use it there and don't use it in a global context. I don't know.
Okay, so I think I understand. I think maybe next time we should probably revisit the conventions that are in the CBOM, and then we'll try to tie that into maybe what we need for configuration to be able to capture all the nuance, padding, and everything else that we want to capture.
Lars pasted something that was interesting and actually awoke some dormant brain cells. Is that the encryption type, seeing the encryption type in the table and the referenced URL. I've seen in common encodings like that to combine the different usages of algorithms with the cipher and the algorithm and the strength and all those things, or so that's interesting.
Yeah, I had to do this for Kerberos, where I needed to find out all the strings supported and so on. And it wasn't obvious, so that's why I did it. And I didn't find a single standard, as you hinted at, for these names basically. And yeah, it's very different all over the place, unfortunately.
We have something similar, our convention, just looking at the Kerberos page.
I think that specific, we're not trying to create a registry or a concrete type, but I think that as long as we're capturing the information that would go and be combined into types, that might be interesting. Like I said, an IRI with paths, encourage an IRI form or something, or URN form or something. I don't know.
Yeah.
But each of the independent, information pieces have to be there as separate, I believe, fields. I think they are today in the proposal.
Okay. License compliance absolutely applicable. Assemblies. Can you have nested cryptographic algorithms? Would that be a thing?
Oh yeah, absolutely. That obfuscates things, double encryption, triple encryption. That's very common. That's part of the black. That's part of a lot of these things are kind of stepping over the black book, So.
Yeah, I mean, I know, like, from an implementation perspective, right, you can, hey, I can encrypt it this algorithm, then I can encrypt it that algorithm. But from an asset perspective, they're 2 separate algorithms. My question is, from a bill of materials perspective, would you actually need to combine the 2 to create something new?
So you mean nesting? you mean there is an algorithm A that internally uses an algorithm B?
Yeah.
Like that, yeah. I mean, yeah, we often have this like in quantum safe algorithms.
Okay.
They all use, most of them use a variant of Ketchuk or SHA-3 internally.
Okay.
I mean, like there is this CBOM we have in Open Quantum Safe. There, we, for example, we list SHA-3 as a component, right? And then we add a dependency from we say, okay, dilithium 2 depends on SHA-3.
Right.
It's actually kind of an interesting discussion because it makes me think about, working outwards from the data you're trying to protect. Like,
Mhm.
like here's an asset. So it's like I was part of it was teased by the streaming concept. So you either have, some document you're trying to encrypt, or you're trying to encrypt a transmission of some information over the wire, and you use different algorithms and ciphers to do these different tools for the job, but there are different things you would do to prep the data or prepare the data. And now the padding comes to play. It's kind of like a workflow of how you prepare the data and versus for different uses. It could be the same data, but in different cases you would use different things depending on the target or destination or transport vehicle. Well, it's interesting.
Isn't it this mostly defined by the protocol that you use? Say,
No, I mean, it's preparing the data. It's like, again, it's like, if let's say you're using it to create a tamper-proof message, what's your salts? What's your, what's your assembly? I mean, maybe it's a slightly different concept, but how do you put all the information together that's used to actually encrypt the data for that specific transport? If I'm storing it on a disk, or if I'm storing differently, I prepare it differently, I salt it differently, or I add different extra pieces of metadata to the data before I do these things. Are these things even worthwhile capturing? But it goes back, assembly is prompting these thoughts. Because I know when we transmitted, movie data, we did different things for different transports or different purposes.
Do we want to, you brought up the concept of salts. Do we want to, I mean, you can obviously have a salt for like the entire thing that you're trying to encrypt. You can have salts like per data component or data field.
Exactly. Yeah.
Is that something that we want to try to capture or not?
Maybe not, but capturing the use case. I think
Okay, good.
we actually did progressive things where we actually had a progressive approach, where as you decrypted or encrypted or decrypted things, you would progressively change what you would do.
Mhm.
And the receiver and the sender agreed upon, based upon their key management blocks, device IDs, they would do different things progressively. So it's
Right.
interesting.
we have one of the crypto assets types is related crypto material. And there we have things like salts, initialization vectors, public keys, private keys. So yeah, try to come up with a more or less exhaustive list of crypto material, right, that is involved in crypto algorithms, I think.
Yeah.
Useful
So
as well.
the funny part about all this is, like, our own CISO office is afraid of producing bills of materials as they are today. They're just going to flip out with including this level of detailed information. They're going to flip out. So I'm feeling we're going to have a conversation between Michael Osborne and others, and some people in our leaders in our CISO org. Anyway.
Well, that's why we need to, again, it's one thing to be transparent about the algorithms that are used, and that sort of thing. It's another thing to start, in my opinion, crossing the line to include things like salts that would be potentially a roadmap to the attacker, right?
Yeah.
Like
exactly.
the M-bomb stuff is clearly a roadmap to the attacker, which is why we externalize it, right? We recommend that you externalize this from your SBOM. And we might want to create some guidance, right? There should probably be a CBOM guide on what it would be, you know, what would be acceptable to actually communicate, especially when it comes to the algorithms and their potential weaknesses. And then, you know, delineate that there's these other things that you could potentially communicate as well, but, you know, that could definitely help your adversaries reverse engineer some stuff.
No, and that's exactly the fear, is the fear
Right.
of an early SCA tool, you know,
Right.
you know, uncovering a vulnerability before it's fixed, and somebody in the product team releases the SBOM that has an unfixed vulnerability. That's exactly the fear. But
Yeah.
but internally, if you're working on the CERT team, situation response team, you'd
want to know this.
You'd want that information, right?
It's all about, yeah, and it's all about, which I think actually I think we're answering our own question, Matt. It's all going to go back to SCVS. Eventually, everything that we're doing here is going to have to be described in SCVS with difficulties and that sort of thing, descriptions, and then profiles for like different types of internal and external stakeholders for cryptography bill of materials.
Yeah.
Yeah, I
I
mean,
was
this
actually
goes into implementation details, right? And how you configure things internally, right? And that's information I think that is not needed, let's say, for the kind of, let's say, vulnerability analysis, right? Policy checking, what you would maybe want to do externally, right? Perhaps it would make sense to have to say what are minimal things that are kind of needed, right, in a CBOM if you want to use it externally. And yeah, and then for if you have internal stakeholders, right, then it's you can expand on it, right?
So my philosophy always been, you know, we have the data, we have to make a place for it and structure it properly and model it properly, but you know, and even so, we have required fields and not required fields, and we have descriptions of whatever. But it goes back to the learning from VEX data, that just seeing the data, even if it's not required or it's not part of the minimal set recommended, just seeing a placeholder for that type of data freaks CISOs out. So anyway.
Yeah. I mean, there's also the question if we actually want to capture the actual data, so the salt or, for example, the key, because that is not what we are currently doing. We are just capturing the metadata, so how big the salt would be, or how, I don't know, how big the key is, the key size, and all the stuff. So if we capture actually the value of the actual data, then it's a shift in what we currently approached.
Lars, you had your hand up?
Yeah, I've kept quiet because I didn't want to derail your discussion. But because it's so close to the end, if I may, just for 2 minutes, bring something up that's a bit different to what you were mentioning. Is that okay?
Yeah, go ahead.
According to like the use case bit from the beginning, because I'm not a crypto expert, and I'm like, I know quantum stuff. I've heard the first time of this D algorithm that you mentioned. So I'm not dilithium. So this is not my world. I just wanted to mention like the use cases that would be useful for us or for our customers, which is why I found your comment useful. And I saw some of it in the IBM in your CBOM README, but not in the specification, but I haven't read it all. So what would be useful for us is like certificates, having a standardized way of monitoring for expiration. I know it's got nothing to do with cryptography, like, but it would be super useful for our customers to have one standardized way of seeing when their stupid certificates expire, because they all seem to be surprised by it all the time. I know we live in the let's encrypt world, but it still happens all the time. And I did see a not valid before thingy in your specification, but I didn't see anything about expired certificates, but I might have been wrong about that. So that would be useful. Same for tokens. I see that you mentioned tokens in your README, but I didn't see anything obvious in the spec itself. And it would be useful to see like what kind of tokens does this application use? Does it have like a token to access the GitHub API, and a token to access the Jira API, and a token to access the whatever API, just to have an inventory of what kind of tokens, like OAuth or whatever tokens, and a thing has. Maybe all of this is included in the spec already. As I said, I'm not an expert in it. I haven't seen it yet. I just wanted to mention what use cases would be useful for our customers. They are not as far advanced as you are thinking, probably, our customers. And then policy enforcement, and this goes to a very low level, like we don't want DES encryption, or a high level. They are much like our policy at our bank says that we can't use this encryption algorithm, and they are not concerned about quantum stuff at all yet. So we are at a much lower level yet. And so those would be use cases that would be useful for us or our customers. I'm not sure if this is what you're thinking about here as well. I didn't want to derail the discussion, but these are some things that would be useful for us. But I'm not the one who's going to do the work, so I just wanted to have this as input, and yeah, I'll leave it at that.
That's very useful feedback, right, about that use case, at least for I think for us. Yeah, with certificates, I'm not sure if we added that in only in the 1.1 version, but there's a not valid after field as well, which I think
Okay, I missed that then.
to monitor the expiry. And but tokens, we have this related crypto material asset type, which can be of the type token. Also, you might have just recently added that as well. I think that use case should be covered as well in that case. And then yeah, one like weaknesses, right? I mean, the quantum safe thing is maybe the most prominent at the moment, right? But it's not the only one, right? So I mean, just it goes beyond that, right? I mean, finding uses of MD5 or SHA-1 or algorithms that are broken, right? So that yeah, I think that's a very natural expansion of that quantum safe use case.
Okay, yeah, I just grabbed the README, and that there it only mentioned token once, so I wasn't entirely sure. So thank you.
Oh, that's great. The use case for certificate expiration and whatnot is certainly valuable. The amount of trouble
Also-
organizations go through to just be able to capture that information is crazy sometimes.
Yeah, I just typed a few things, random thoughts in the chat, about analog to license expiry. Because we have all the commercial license stuff that was just added. And the
Yep.
question is, do we, who are the issuers? Information about the entities that issue these things,
That will also be useful, yeah, indeed. License expiry, yeah.
Okay. Well, we're at time. I think this document will eventually turn into something a little bit more readable. But no, thank you for all the input. This is all really good stuff. So thanks for joining, Lars. Appreciate appreciate you contributing to the group. Basil and
having me.
and Matt, appreciate your contributions as always. And I'll go ahead and post a recording up on YouTube once Zoom actually gives it to me. So with that, have a great rest of your day, everyone, and we'll talk soon. Cheers.
Bye.
Bye-bye.
Bye.